Hello student. Last session we have to study now class 10 circle. Remaining problem are there solving there. Here the problem set 3. 10 problem in last session is now solved. Then 11th problem. Problem is there. Draw a circle with center A, B, C. Each of radius 3 cm such that each circle touches the other two circles. Then we have to prove now. Let the circle be center ABC with radius 3 cm. Here the center of both circles join together and touches externally at point P, Q and R. Hence their external touches center of the distance between the external touches of center is 3 cm and 3 cm is 6 cm. Each of the side of the triangle is 6 cm. Then triangle ABC is now equilateral triangle. Why? All the sides are congruent. Then by theorem of touching circle, then in this matter A dash P dash B, B dash R dash C and A dash Q dash C. Here the A P is the point between A and B, R is the point between B and C, Q is the point A and C, and these 3 points APB, BRC and AQC are collinear point. Then this triangle is known as equilateral triangle, and we have to draw a 3 circle touches at the point P, Q, R. Here example number 12. Prove that any 3 points on a circle cannot be collinear. In this matter, A, B, C are collinear. Prove that R cannot be collinear. Then we have to assumptions. Now given here, circle center of the circle O, point ABC are on the circle. To prove that ABC cannot be collinear. Construction now. Segment OA, segment OB and segment OC can be dropped. In this matter, ABC lie on the circle. Then OA congruent OB, radius of this circle. OA congruent OB, radius of this circle. Then we have to draw point O is equidistant from A and B. Equidistant from A and B. In this point C is B and C is equidistant from point center of O. Why? B and C and A lie on the circle. Here OA, OB and OC is the radius of this circle. In this circle, there are radii is congruent now. Point O, here perpendicular bisector of segment AB and segment BC. Perpendicular bisector of AB and segment BC intersect at point O. Let's assume that ABC are collinear. Their perpendicular bisector of segment AB and BC are parallel and do not intersect. Perpendicular to same lines are parallel. This contradicts statement. Our assumption is false. Then point ABC cannot be collinear. In this circle, here point A, P, S and Q is on the circle. Here line PR is the tangent now, touches at point Q. Touches at point Q. In this figure, line PR touches at circle point at Q. Answer the following question with the help of the figure. Then first question is, what is the sum of TAQ? TAQ. TAQ, what is the sum? And TSQ. TSQ. Here TAQ and TSQ. In this draw segment QS, here the ATSQ are cyclic quadrilateral. In this matter, ATSQ are cyclic quadrilateral. Here the theorem of cyclic quadrilateral says that opposite angles are supplementary. Then angle A, angle S plus angle S is equal to 180 degrees. Then by the tangent secant theorem, then second question now, find the angle which are congruent to AQP. AQP. ATQ, ATQ and ASQ are congruent to AQP. Congruent to AQP. QAS here this angle QAS and QTS and SQR and QTS are congruent by tangent secant theorem. Then fourth number question, angle TAS is equal to 65 degrees. Here the angle TAS is the 65 degrees. Find the measure of angle TQS. Find the measure of angle TQS. TAS and TPAS are described in the same arc TS. And angle TAS is equal to half measure RTS. Now the measure RTS is equal to twice of the 65 degrees, that is 130 degrees. Hence measure RTS is equal to 130 degrees, and then we have to find their angle my measure RTS. Question number 5, angle AQP is equal to 42 degrees and SQR is equal to 58 degrees. Find measure of angle ATS. Then angle AQP is equal to ATQ. It is a tangent secant theorem. It is a bi-tangent secant theorem. And angle QTS here, then is equal to SQR. Here the tangent secant theorem. Then angle ATS is equal to ATQ and QTS. Then ATS is equal to 42 degrees and 58 degrees. Then it is equal to 100 degrees. Then another question here, 14 number question. O is the center of the circle. In the PQ and RS is the chord of the circle. Hence chord PQ congruent chord RS. If POR is equal to 70 degrees, and measure RS is equal to 80 degrees. Measure RS is equal to 80 degrees. Find measure RPR. Here the angle of POR is the vertex of point O. O is the center of circle. Then it is known as the central angle now. And a central angle and corresponding arc are the same. Then measure RPR is equal to 70 degrees. Then another question, measure RQS. Measure RQS we have to find now. Here the PQ congruent RS in one circle, then it is a measure are same, that is 80 degrees. Here all circles, same measure of the all circles are 360 degrees. Then 360 degrees minus 80 plus 80 plus 70, that is 360 degrees, is the measure RQS. Measure RQS is equal to 360 60, 200, 110, then 150 degrees. Now the measure RQS here. We have to solve now. Measure QSR. Then QS is 150 degrees plus 80 degrees, that is 230 degrees. Now the measure RQSR. Here the question number 15 now. We have to see now. We have to draw two chords intersect at point T. Intersect at point. Any measurement in this matter, any measurement of segment, we have to draw internal chords of the circle of theorem. for using this circle. We have to solve this problem in last session. Then it is also a problem solved this session, last session. That is, there are two rays intersect at point A on the exterior of the circle. That is, the theorem uses now by theorem of external division of a chord, and we have to find any segment. In this matter 17, there is the activity now. Here there are two parallel lines, EF and GF, and draw GF. GF is the transversal in this matter. There are two angles now, are alternate angles are congruent. Then draw segment GF, EFG congruent, FGH alternate angles reason there. Then EFG, major angle EFG is equal to half major R EG, half major R EG. In this matter, major angle FGH is equal to half major R FH, half major R FH. Describe angle theorem. Here EG is equal to FH. R now their chord EG is equal to chord FH. Then corresponding chords of congruent are shown in the same. Then 18th problem. Here the OP is the vertex of O. To draw a ray touches at circle at point P. Then another vertex of the ray OR intersect at point on the circle Q, and R is the secant. Now here tangent secant segment theorem, OP square is equal to OQ multiplied by OR. In this matter, any segment we have to draw, we have to find there. In example 19, here the example 19, in the figure circle is center C and D touches internally at point E, D lies on the inner circle, chord EB of the outer circle, intersect inner circle at point A. Prove that segment EA congruent segment AB. Draw segment ED and DA. Then C is the center of circle, smaller circle, and D is the bigger circle of the center. Then we have to ECD is the collinear now. Then we have to draw in smaller circle. C is the center of circle and ED is the diameter of the circle. Then major angle EAD is equal to 90 degrees. Why? This is the angle described in a semicircle is right angle. Then in bigger circle, D is the center of circle and EB is the chord. Then we have to draw DA perpendicular EB. Then it is also 90 degrees, and perpendicular drawn from the center of circle to a chords are bisect each other. Then both segments are congruent. That is, EA is equal to EB. Then true. In matter of 20 example, in figure segment AB is the diameter, O is the center of the circle, the bisector of angle is CB, ACB, intersect at the circle at point D. Here prove that segment AD congruent segment BD. In this matter, there is an activity now. Here we have to see now ACB is the bisector of BD is the bisector of AD. Then angle ACD congruent angle DCB, then it is also a 90 degrees. Why? Inscribed angle theorem in a semicircle diameter. then it is 90 degrees. Here the each angle is 45 degrees. Then angle DCB is equal to 45 degrees. Then both angles are congruent and angle of the both sum of the angles of both are 90 degrees. Then we have to see now C at D. Draw OD. OD is the area of the circle and radius perpendicular to the diameter of a chord of the circle is 90 degree. Then point A and B is equidistant from D. There here AD is equal to BD now. Then stop.